All right, number 4. We're going to write each set as an inequality, and then we are going to graph. Okay, so to write it as an inequality, first what I would suggest is taking a look at this maybe as a graph first, honestly. It may be easier. So if we look at just that 1 to 3, right? If we're on our number line, and here's 1, 2, 3, 4, 5, 6, 7. All right, so we would have an open circle at 1 and an open circle at 3. That's just this first part. If we were to do the next one, we would have a closed circle at 2 and a closed circle at 7. Now, because we want the intersection, all we want is the overlap, so what both of them are doing. So remember, this is telling me overlap, so I just want the part that they both include. So if I do that, which might actually be the easier way to graph first, like this, it looks like we're going from 2 to 3. Because of that closed circle and that blue line included that, we're going to put a closed circle at 2. But 3 was not in this set. Remember, it did not include it. So that'll be an open circle. And everything in between 2 and 3 is in both sets. So there's my intersection. Now I can write this as a inequality. So we're going from 2 to 3. So as an inequality, that would be 2 is less than or equal to x is less than 3. If you wanted to write it as a set notation, that would be good practice too. So it would be the boxed off 1, comma, and then 3 with a parenthesis. So this is the inequality, and this would be the interval notation. All right, so in B, the only difference is now we're not talking about intersection, we're talking about union, but I would do the same thing. So again, 1, 2, 3, 4, 5, 6, 7. We go from, 1, but open circle to 3, and in between. And then we're going from 2, but including it, to 7. Now, this time we want the union. The union means we want to use everything. So when we're doing the union, we're going to go from 1. 1 is not included in any one, so we'll have an open circle there. 7 is included, and everything in between. So as an inequality, we're looking at 1 is less than, x is less than or equal to 7. Or in interval notation, we're looking at parenthesis 1, comma 7, bracket. Absolute value and distance. So if a is a real number, then the absolute value of a is written as this. So we see the absolute value of a symbol, and then it depends on what's happening. It's kind of written as a piecewise function, if that sounds familiar from Algebra 1. So if a is positive, then we just get a if a is greater than or equal to 0. We get negative a, or the opposite of a, if it's less than 0. In other words, turn it positive. So if I have the absolute value of 4, we get 4. If I have the absolute value of negative 4, we still get 4. All they mean is you're taking the opposite of what's inside if it's negative. So the opposite of negative 4 is 4. Turn it positive. That's really what we're doing, because we're talking about distance, and distance has to be a positive value. Distance is how many you, or how far you are from something. Okay. So we are going to evaluate very quickly the absolute value for each of these. So the absolute value of 3 is 3. The number 3 is 3 units away from 0. The absolute value of negative 3 is still 3 because it's 3 units away from 0. The absolute value of 0, well, is 0 because 0 is 0 units away from 0. All right, this is where things get a little bit tricky. 3 minus pi. So let's think about this for a second. 3 minus pi. Pi is about 3.14. So that's like 3 minus 3.14, which should give us about, I lost my spot, which should give us about negative 0.14. Okay, so that means right now the answer would be negative, right? So if we're taking the absolute value of that, I would want my answer to be positive 0.14. So how could I write that? But it's not exactly 0.14. What if I subtracted in the other order? Pi minus 3 would be 3.14 minus 3. That would give us that 0.14. So we can say our exact answer is pi minus 3. All right, in E, we have the square root of 2 and then minus 1. And really, this is just over the 2, not over the 1. Well, I guess it's the same question. Is the square root of 2 minus 1 a positive value? Well, the square root of 2 is certainly bigger than the number 1, right? So the square root of 2 minus 1 must be positive. So it already is a positive answer, whatever that horrible, irrational answer is. Properties for absolute value. So we have that the absolute value is always greater than or equal to 0, so it's always non-negative. When we take the absolute value of a number, of a real number, the absolute value of its opposite is always the same. So the absolute value of 4 is the same as the absolute value of -4. When we take the absolute value of a product, it's like we can separate it just like we would, just like we could, do other separations with, say, radicals. So the absolute value of A times B is the same thing as the absolute value of A times the absolute value of B. And then for number 4, we see division, the same thing. We can pull them apart. We can separate addition. We cannot separate addition and subtraction. We can separate multiplication and division. So can separate multiplication and division, cannot separate addition and subtraction. Okay, please keep that in mind. You can only separate multiplication and division because really the value is the same. We're just making sure the answer is positive, right? If I multiply 2 times 3, I get 6. If I multiply 2 times -3, I get -6. So the only difference is the sign. Whereas addition and subtraction, it makes a big difference. Okay. So if A and B are real numbers, then the distance between points A and B on the number line is going to be the absolute value of the difference. You might have even seen this in geometry. So if we want to know the difference, or the distance between -4 and 9 on the number line, so here's -4 and here's 9. I mean, I could count. There's really nothing wrong with that. But if I want the distance between -4 and 9, all I have to do is the absolute value of the difference between them. In reality, it doesn't matter which one comes first. We could do 9 minus -4, or we could do -4 minus 9. It does not matter. So that would be the absolute value of 13, which means they are 13 spaces apart. We could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But if the numbers are larger, counting just would not be practical. Again, we're going from -8 to +2. We're going to do the same thing. So the distance, D, from -8 to 2 is going to be the absolute value of 2 minus -8, which is going to be the absolute value of 10, which is 10. And surely if we count, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.